This was a genuine project which I undertook on business needs regarding water leakage. Water leakage is a major problem for all water companies. Some information was made available to me through a hackathon about what happens in Southwest Water. I'm not 100% sure that this is actually what happens, so this is just my take on it. However, this is a genuine business need. Water leakage is a massive problem for all water companies where they have a large infrastructure. Leakage happens all the time, and they have to try and combat this. So I was thinking about how tech can help on this problem, and my suggestions were to use a predictive heat Aquamap to predict leakage. So high heat means a lot of leakage basically on the Aquamap. The goal is obviously to identify and prioritize leaks according to how much damage they would cause, and to use machine learning and Bayesian simulation to make this possible. So this was my thinking, to produce this Aquamap, which would be obviously available on mobiles, phones, smartphones, tablets, maybe laptops. My information was, I'm not sure if this is correct, but this is what I was led to believe, that there are sensors collecting pressure and flow data at 15-minute intervals. Data goes back for 10 years, so there's obviously a lot of data from this system. This could then be used for a time series analysis to identify underlying stochastic trends. So then this could be used for machine learning to train a predictive app based on not just machine learning but also Bayesian simulation. So this is an example of an Aquamap. So you can see that the most leakage is looking like it's occurring where there's more blue, for example here and here. Medium levels of leakage are in green, and then it's getting less where we go onto yellow, and then finally the lowest levels of leakage will be where the red or the dark colours would be. So one of the most important concepts here is the minimum night flow. So from 3 to 4 a.m. we have the lowest usage in any system in the UK, for example. This would enable to see the leakage, because there's obviously a reduction in pressure and increase in flow, in spite of the fact that this is a time when very little water is being used. So therefore it would indicate that the leakage is the highest. So this is why this night line situation is important. So obviously there have been a lot of other studies, and I include here some of the ones that I found very instructive. One of the key indices is the infrastructure leakage index. So this is found by taking current annual real losses and dividing by unavoidable real losses. So unavoidable real losses are in every system, and you cannot mitigate against them. However, obviously we want to reduce them, but the most important thing is trying to really look at what can be controlled and what can actually be addressed. The lower the ILI, or the infrastructure leakage index, obviously the better the system. So time series analysis is very important to look at the ILI, because it gives an indication of underlying stochastic processes, i.e. processes related to the actual functionality of the system in terms of the pipes, the joining of the pipes, the laying of the pipes, taking the processes away from seasonality to look at actual patterns. So the predictive Aquamap would use machine learning to try and predict trends based on these underlying stochastic processes which we would have found through ARIMA. So Bayesian simulation could be used to calibrate the two very important parameters C and alpha. So C and alpha are related to the power leakage equation, which is C times H to the alpha. Now H is the pressure head differential. C is the leakage coefficient to do with pipe characteristics. So things like pipe degradation, the traffic, the external stresses, environmental conditions like weather, temperature, corrosion, and soil type. And alpha is the leakage exponent, about the hydraulics of the leakage. So I suggested stepwise linear regression and generalized model to try and understand this whole situation. So this is an idealized scenario where leakage would be generally decreased due to an understanding of what the underlying processes were and being able to predict future losses. So I looked from some of my reading at where there'd been a lot of successes, and the one of the main studies that showed massive success was a Norwegian hydraulic network, where there has been 40% improvements in the systems. Obviously there is a massive investment cost you can't in the infrastructure, so it's you know, that obviously has to be balanced. However, the World Bank estimated that there could be up to 70% water losses in a system which is about 50 billion cubic litres globally. So this is a massive problem, and just shows how it really can be an area for fruitful machine learning and Bayesian simulation to help understand what needs to be done, because obviously investment is expensive. Thank you for your attention.